So welcome to the, I have lost count, more than 10th edition of the Heat Pump City of the Year Award in 2020. You can imagine that we had in mind to have a much nicer celebration with everybody on board, with champagne, bubbles, canapes, a nice dessert with Brussels pralines for everybody in location in Brussels. And we really tried hard to do this. We moved the event presentation to the fall, but the pandemic didn't help us here. And so in the end, Brussels is locked down. Many other countries are suffering from a very limited public life, and we too. So we have to toast and celebrate today online. With all the dryness, I want to do that too, but I brought only water since it's still in the morning. So this year's celebration, this year's event was most difficult for all the jurors. I have to thank my co-jurors for going through 32 presentations of very good projects, and we agreed that this was more and more complicated. We prepared a few photos about this. So we had to judge in 4 award-winning categories: the Heat Pump City of the Year Award, the Decarbonization of Building Award for projects that look at individual buildings, but always with a very good multiplication potential. Then we had to look at DecarbIndustry. And here is Dave Pearson, obviously trying to get in. If you excuse me, I will just pick him up. Dave, you're live now, but I am also live, so let's keep it quick. I will give that to Serena. And then I will continue the moderation. Super, thanks. Serena, Dave cannot get into the meeting. Could you please arrange for him to join us here? Otherwise, we'll have quite a bit of a problem in organizing the presentation of the awards. So where was I? Decarb building. You can see some nice photos, because one of the advantage of this event is now that we are getting great photos of great projects. We are increasing the visibility of heat pump projects across the world. And what we recognize here is that you don't see this. Heat pumps are all around us as much as renewable energy is all around us, but typically it's not visible. You see the photovoltaic cells on the roof, you see solar thermal cells on the roof. Sometimes you see a red compartment where the energy central is located. Some of the smart CHP guys have actually created transparent installations, and one of my favorite projects from the past was also the 50/50 project in Norway, where they also used a huge heat pump in a transparent enclosure so that everybody could see where the energy that is providing heating and cooling is coming from. So that's decarb building. Then we have decarb industry, because we realized that it is most unknown. It's most unknown that people understand that heat pumps can also work in industrial processes as much as they can provide whole cities with heating and cooling. And then we have the next generation heat pump, a category where we say this is how we think it should look like in maybe, we thought 10 years, but it's moving very fast. And actually, I guess the distance from what we think is innovative and what we are doing today is actually getting smaller. So this category, next generation heat pumps, is meant to indicate where the trend is going. Typically, we think that many of the projects that we looked at are actually quite next generation heat pumps already today, because we saw that the vast majority of the projects were integrated. They were looking at heat pumps as integrated systems in an energy system, providing demand-side flexibility, integrating different energy sources, and integrating different building types, also old and new. So let's look at the applications. 32 applications received. We had one that was very interesting, because it was not really a project in itself as a building, but it was a lab that we had to recognize outside of the categories. But nonetheless, it was very interesting to see that also the type of involvement of science and R&D is picking up this prize, and maybe we should have something for on the scientific level in the future. Then we had And I will not go through all of them, because if I spend only 30 seconds, then we will also spend already 15 minutes, but we will make them all available on our heat pump map. We had old buildings. We had a combination with CHP and heat pumps. We used different energy sources. Water, ground, wastewater was becoming more and more interesting. You see this project here, energy tunnels. We had the redevelopment of buildings as well as new buildings. We had very interesting, and you could say formerly deemed impossible for heat pump heating, industrial applications and buildings that are now heated by heat pumps. Whole cities applied. We had greenhouses, the Lastly heat pump. We had some data parks. Data centers are the new sun of the 21st century. They will provide energy to us all the time. So it's absolutely essential that we make that useful. We had the use of waste heat from air conditioning of buildings, also a very important part. We see that in passive houses, heat pumps become the standard. We also see that the multiplication, and you see this very nice visual here, the multiplication of integrated solution is becoming a future that is attractive. And that's one thing that I conclude from this whole judging process. We saw so many great projects where you would say, I want to live there. I want to live in such a city that is taking care of its environment, that is taking care of an efficient use of energy, that is taking care of its citizens. So the benefit of heat pumps, as much as we heat pump geeks may want to stress renewables, energy efficiency, CO2 emissions, the benefit of heat pumps is actually a healthy and an interesting and attractive environment. You see less rooftop space taken away from air handling units. You see things moving underground, and you see that actually the climate in the city can improve. Modernization is very important. We see this Albion Towers project here, very interesting one. Then I said different energy sources, lake water, and so on. But I should stick to what I said. I should not mention them all. So all in all, what I can say is we saw integrated solutions using all energy sources, but all providing an attractive result for the citizens and the users, the industrial users in the future. With that, I would like to introduce my co-presentators this morning that will also present the different prizes. We have Dave Pearson that I still don't see on the screen, but he will present the Heat Pump City of the Year winner. And I will not tell you who that is. We have Thomas Lecker that will present the Decarbuilding Winner, the Decarbuilding category winner. Then we have Jussi Hirvonen who will present the next generation heat pump category. And we have Wim Boydens who will present in the Decarb industry category. The event then, everybody will take, and luckily we have the prize winners on board. We checked that already, so they're all here. And then we will allow you to answer questions. We have around 15 minutes foreseen for that. If you have any immediate question on the technical details or on something that you don't understand, then please bring that in. And here I see that Dave has joined us now, so I can come to a close in my presentation. I would also like to say thank you for the rest of the judges that has also helped us. All in all, we were 8 judges, and we concluded that it was a very interesting experience, something that we should do again in the future, maybe with a streamlined process, because if we go to, let's say, 50 applications, we need to rethink the judging process. So without further ado, as we say in Shakespearean English and English altogether, I think I hand over to Dave Pearson and give him the floor to present the winner of the Heat Pump City of the Year overall award, and then we go to the different categories. But luckily I can tell you that the top 4 that we judged by points were also the winners in the different categories that we selected as judges. Dave, please.
Thanks, Thomas. I guess carrying on your Shakespeare thing, hopefully this isn't much ado about nothing. But it's been a fantastic process again, as Thomas said, too many. I think we were well over 35, so very, very difficult to keep judging this. All of them brilliant, all of them let's get it out there, better than burning gas. So very pleased to see so many people doing that. But there's one winner. It struck the judges because of its complexity of what it was doing. As many people involved in heat pumps know, it's not so much about the technology, but more about how to get these projects out and get them deployed. And this one certainly overcame several hurdles in that. So the winner is the team from Together Housing, I think it's titled as, and congratulations to them.
Thank you very much. I'm delighted to have been selected. It's a great reward for a lot of effort put into a really important project, I think, and so we're delighted to share that. Should I go on and do my presentation, David, now?
Yes, please, Patrick, you can already start sharing your screen. Thank you.
Bear with me 1 second. Okay, everybody see that? Okay, this is about the project that David just introduced. It's about how we rolled out renewable heat in social housing for Together Housing Association, which is part of Together Housing Group. That team obviously involved ourselves as Together Housing and made the somewhat substantial investment, but also Kenza Contracting and Kenza Heat Pumps, leading UK-based both manufacturer and installer of heat pumps, and Procure Plus, which is a collective procurement organisation for social housing in the northwest of England. And just to mention Ellie Vogue, who was very helpful in preparing this application for this competition. A little bit about Together Housing. Together Housing is a registered provider of social housing in England, and we own and manage around 37,000 properties across the north of England. And like many social housing bodies, we are now committed to carbon reduction strategy to achieve net zero over the next 20 years. And central to that is our approach to the electrification of heat. It's a massive part of our decarbonisation process, particularly because about 31,000 of our properties have gas, and a large part, and the rest have electric heating already, but it's a poor form of electric heating and night storage heating, and I'll come back to that in a minute. And the solution that we are proposing to decarbonise that heat is essentially based around heat pumps. They're central to that transition away from fossil fuels, combined with our investment in retrofit of insulation into those properties. But what we're trying to do is what we call a triple bottom line. So all these investments must provide tangible benefits for tenants. They must reduce carbon, and we try to find ways to make this work as a sustainable financial investment as well. We'll come back to that again later. From a tenant perspective, this started because we had about 2,500 properties, mainly flats and apartments, where there'd been long-standing complaints from the tenants about the existing heating system. That's because it was night storage heating, so by design, it was not centrally controllable. You have to plan in advance when they're going to be cold 24 hours or not. And if it is cold, it tends to run out of heat in the following afternoon. So a lot of tenants actually didn't use it, and they go to the supermarket and they buy a plug-in heater that they would run on peak electricity rates during the day. This leads to poor health and well-being, people heating only one room, or they're having extremely large bills. So we looked to a solution of a shared loop ground source heat pump, where we could provide both a shared loop energy gathering system, but each individual tenant would have their own heat pump. The benefits of this were that we didn't have to develop a separate billing system. but the tenants will continue to pay their own electricity bill, just as they had now, but have a much more comfort-derived heating and hot water system. For the business, this is also important because we found that properties where we had night storage heating of this type had higher tenant turnover, so the void rates were more. This is a problem for us in the business. The more that tenants pay for their disposable income on heating systems that are expensive, this reduces the ability to pay their rent. So this has a strong footprint in our business case. The other issue for us is, of course, that although heat pumps, as has already been talked about today, have been around for a long time and are used extensively across parts of Europe, in the UK, these are relatively new. So the first thing we had to do was actually show people that this wasn't magic or witchcraft. So we had to do a pilot scheme, and we chose 2 8-story blocks, about 124 flats. And we looked at both at how we engage the tenants, how the process of installation worked, because this was quite invasive into the houses, because we had to completely put in a new heating system, which a wet heating system in this case. And so we needed to take the tenants with us, and then we needed to see whether this made a difference to their quality of life after. And so we went through that process, and we delivered reliable, affordable heating benefits with a central programmer, simple for them to use and simple for us to maintain. So having established the pilot and demonstrated that this worked, we then went out to a much bigger program for targeting the rest of our flatted and apartments where there was night storage heating, and we did that going via Procure Plus. Now that was useful to us because Procure Plus had already corralled the market. They established a heat pump framework, both in terms of the heat pump technology and heat pump installers, particularly shared loop installers as well. So the market was already there and enabled us to go and have an efficient procurement process, and Kenza were the winners of that process, and we went into a contract for the delivery of the remainder of the properties in our portfolio that were targeted, and we had about 800 of those at that time. That's varied a little bit since. In fact, it's gone up a little, but this was not a one-size-fits-all. Each individual site had to be treated as a project in its own right. Needed to be, because they're all varied, both in terms of the type of property and its location, the surrounding area for drilling, and so had to be costed separately. The projects all benefited from the non-domestic renewable heat incentive provided by the UK government. That also had to be calculated in each case, and to see whether we could benefit from what's called the energy company obligation to help fuel poverty for the worst performing properties. And so each individual project was appraised by us to see whether it stacked up in terms of from a financial perspective. So in each case, we had a rolling program of design, pricing, we could sign that off, but a massive part of what we did was that tenant consultation. So we were asking tenants to engage in what for them is very much a new technology, which is going to be very disruptive to their home. But we've found a very willing audience, particularly in terms of replacing night storage heating, and tenants, many of whom were elderly and sometimes infirm in these locations, very willing to accept the disruption that was coming in order to get this better heating system. It's kind of an indicator of how important this was for them to participate. Earlier this year, we'd completed about 473 properties, with another 510 to complete in 2020. So a very sizable program located across the kind of north of England. And in 2019, the installations that we were contracted to make made up roughly about 10% of the whole of the ground source heat pump market. So very much a trailblazer in that respect. In terms of the project outcomes for the tenant, well, obviously we went back, we've interviewed tenants and also collected data, and we found increased comfort for tenants, both in the way they feel, but also the way they feel about what they're paying for. They get a whole house system because they've got radiators and a wet heating system. And they've seen up to 45% savings on their running costs, and we've evidenced that through 12 months collection of smart meter data with participating sample of tenants, with reductions from over £1,000 a year down to an average of just over £600 a year. So really quite significant differences in those costs. But they've also found, and again, unlike night storage heaters, that they have a very simple time clock, which allows them to effectively program, plan and control their heating throughout the year. Some evidence that the tenants were appreciative of what we've done, even though there was a lot of disruption, a lot of mud and drilling outside, which was all made good. But also knocking about of the properties in terms of fitting wet systems. We got a lot of thank you cards just to thank us for the change in heating system and how well, and this was important, how well the contractors engaged with the tenants themselves throughout the whole process. So the project itself has sought to maximize its relationship to the income we can get from the government incentive, in this case the renewable heat incentive for non-domestic schemes, non-domestic because it's a shared loop system, even though it's feeding domestic properties. And that's been particularly important to convincing Together Housing Group to make this very large upfront investment. We should recover most of our capital over a 20-year period, but we get a much improved system. Our properties are much more marketable and lettable because of the change in that heating system. Reduced tenant turnover and void periods because of that heating system. We have a low service and maintenance cost now. And a key part of the contract that we let was that Kenza provided in-house training for our repairs team. And we now have a system of how that works, where properties are experience any difficulty. And one of the reasons we particularly chose the shoebox heat pump from Kenza is because that allows us to, if there is a fault, we can quickly and easily take out the pump, replace it with another, so the tenant is not without heat or hot water for any period of time, and the pump can be taken away to be repaired. We are operating on a 20-year life cycle for the pump itself, and obviously there's a much longer life cycle to the array which sits under the ground. All of the repairs and maintenance is, as I mentioned, taken up by our repairs team as we go forward, and the handover as properties become void and are let is relatively simple because this is a very easy to use system for tenants as they move in. What was key for the project, both within Together Housing Group, because we've got a lot more properties that have where we want to transition away from fossil fuels, is that the project demonstrates the scalability of heat pump installations on all kinds of different house types and scheme sizes. And doing shared loop schemes is pretty complicated with all the boreholes that have to be drilled and the drilling rigs that have to come in. But it's proved possible, and we've worked around in some tight spaces around many of our buildings. And I think this is the start of a process where this kind of project can make much greater inroads into the almost default gas boiler position that there is across much of the UK, which will have to be done if we're going to get anywhere near our 2050 committed target by the UK government. One of the things that both the pilot project and the subsequent projects have done is they've generated an enormous amount of interest from other social landlords across the UK. So over 80 different social housing clients have visited our sites to look at what was done, how it was done, talk to the tenants and so on, with a view to taking that away themselves and starting to implement their own programs. There's a kind of need to be shown that it works and convinced that there are no major issues with it. One of the big things for us in terms of installing the heat pump systems is, as an organization, we're extremely keen to work with the revolution that's taking place across our energy systems generally, and in particular, how our heating systems can work with the energy grid as it changes over time. So in particular, we're very keen to use heat pumps alongside solar PV and battery systems. I think has already been mentioned today. We want to be able to provide ways of optimizing and automating heat pump systems with things like solar PV and battery systems, but also potentially use those assets alongside things like demand side response, flexibility to lower demand at peak times on the grid, which could also generate additional revenue from our assets. So this project demonstrated not just how we can change heating systems as something much more renewable, but how those heating systems become part of a much bigger role that we as an organization play in how those heating systems operate, what is their impact on the national grid, and how that derives benefits for us and the tenants. And I'd like to leave that there. Thank you, David. Happy to take any questions later in the presentations. Thank you.
So, David, you want to say some final words?
Gosh, it's even more impressive than I'd realized. That's the challenge of making an application in such a tight format. But it's a really complicated project, and you know it certainly speaks to my personal desire, which is about retrofit and fixing all the old buildings that we have. You know, it's the key area that we have to address across the world is fixing the old stuff. So hearty congratulations from me, and I look forward to hearing even more about it over the years as you carry forward that banner and flag for the whole industry. Well done.
Thank you very much, David.
And I would say I would reiterate that I think it's really an impressive project, and this is the type of projects that we need. As you said, the future is happening now, and this is so important to state that again and again and again. Because also there was a second thing I picked up. You said that in Europe it's known. In the United Kingdom, you had to convince people that the technology works. And that is something that we all have to continue to work on. This is existing technology, and existing technology allows policymakers to be more ambitious. Yeah. So you should have received the prize by now. I don't know if you have next to it. Yes. Because this is, I guess you realize immediately what it is. It's a small figure handing, yeah, and the heart of the person holding the sun. The heart of the person is the compressor. So congratulations from all of us for this prize, and let's make the most of it from a communications perspective.
Thank you very much.
Thank you for being with us, Patrick. And thank you also, David, for introducing the overall prize winner. I take the opportunity, if I'm correctly informed with my small screen here, then you see the jury of experts, to thank everybody that has helped doing this. Dave as number one, but there was also Jussi Hirvonen from the Finnish Heat Pump Association, Thomas Fleckel from the AIT in Austria, Patrick Crombie from Daikin Europe, Wim Boydens, who has a double function today from Boydens Engineering, Nicolas Galavov from he's an architect himself, and then Helen Karlström from E.ON. So you see that we have extended the number of judges, and we are still looking for judges if people want to do it, because sometimes people want to change. So if you want to do that, please do it and apply with us, apply for being a judge. And also, if you are enticed by what you see today, start applying, because now we have introduced a rolling application process. We have a new website. You can see it here, hpcy@ehpa.org. And you can apply from the second week of December, but also check the website repeatedly, because we will bring all the applications on the website to really make the most out of it from a communications perspective. Good. And then we are running a little bit behind time. I take this on my shoulders, that's my fault, but let's look at the second prize. You can see it already on the screen here, Decarb Buildings, and that is presented by Thomas Flecke from the Austrian Institute of Technology. It is a body that is very knowledgeable in integrating different energy solutions into a building and into a quarter. Vienna, they are located in Vienna. Vienna is on the forefront of removing fossil energy from the built environment. So Thomas could talk hours about that, but today we want to hear him talk about the prize winner and the Decarb Buildings category. Thomas, please.
Okay, thank you very much for your nice introduction, Thomas. So it's about buildings, the next award, and I'm doing this job in the jury since some years, and it's really astonishing how much innovative projects we got there. And also the winner this year is one of this category. And it was not really an easy job, but I think we had more or less 100% agreement about the winner in this jury. And it's a project, a really outstanding project, fulfilling different aspects. So it's a kind of holistic planning approach for a really large-scale retrofitting project in the building, including also a really modern proper design. So I think it could also run for an architecture prize as well, not only for a heat pump prize. So it covers also different ways of functionality within the commercial and business application, and in parallel fulfills also the highest building standards. And last but not least, of course, there are a lot of heat pumps included. Therefore, it's also a nice project for us. And for me, as a person, as a researcher, I also appreciate really the way, the methodology, how this thing was designed. So there was also simulation put in there, on the one hand for the energy optimization, but also for the comfort aspects. And therefore, it's for me really a pleasure to present the award to the Gare Maritime Brussels project by Kurt Corvers from the Boyden Engineering Company. So, Kurt, the floor is yours.
Good morning. Thank you, Thomas for this nice reward and recognition of all the work we did on this nice project. I will start to share my presentation. I hope you can see it. Okay. I will keep it short to try to catch up for some time, Thomas. So the Gare Maritime, it's a very old goods station, train station, built in 1902. And that was left about 30 years ago, and on the site of Tour and Taxis in Brussels, and that has now been completely renovated, and you can see it here centrally on the picture. Use my pointer. This is the Gare Maritime building. So this is the digital model of the existing train station, which is quite gigantic. So it's 270 meters long, 150 meters width, and 24 meters high in the big holes. So it was not easy to start a renovation. This was the situation before restoration. It's a huge building, very beautiful as it was. It's not beautiful as it was 5 years ago. So it's a restoration of the whole, and then trying to find some functions to put in this building. Now, after restoration, it is really beautiful and a success. And as Thomas Fleckel already said, an architecture prize will probably find its way also, which was already the case earlier this week from the architect in the Netherlands. The project was awarded the ARC20 award. So I hope some more will follow. I integrated a lot of pictures in my presentation since it's such a nice building, and you can also visit it since it has a lot of public functions, so I surely recommend you to do so. This is another picture of the situation before restoration, so it was really obsolete, the building, and after restoration and integration of 45,000 square meters of office and commercial functions and a central event zone. It has become a covered city, and all buildings that have been integrated inside the Gare Maritime are constructed in CLT, cross-laminated timber, so which makes it even a nicer project. Now the result is 45,000 square meters of energy neutral offices and commercial spaces, so no fossil fuels, all based on geothermal energy, a lot of heat pumps, a geothermal energy loop. I will explain a bit more about it. Lots of PV on the roof, and also, as you can see here in the south facade, we've got building integrated photovoltaics, just to emphasize the sustainable aspect of the building. As Thomas already indicated, we did lots of simulations to find the best appropriate solution for this building. This is just an image of some cases that we have studied for the building envelope of the main halls, but also of the interior volumes. The numbers 9 to 12 we left out. That was the first idea, to also heat the main hall, which is gigantic and which of course would consume a lot of energy. And we studied if we could insulate it very well or use some transverse ventilation, but in the end it didn't seem interesting. So we decided not to heat the hall. The thick installation of the hall, since it's not heated, was not so interesting neither. It's a big investment, very difficult, seeing the historic character of the building, so we did not do that neither. Option 4 and 8, where the cooling demand increases by increasing the insulation of the interior wooden volumes, was also not that interesting. So in geothermal insulation, we tried to find a balance between heating and cooling, and it was not needed for us to over insulate the interior volumes. Option 5 and 6, where we transferred the air from the interior volumes to the big hall to try to increase the comfort of the volume of the hall. It has little impact on the comfort and the temperatures in the hall, while the energy use was higher. And then finally, the option 1 is more like a detailed insulation thing for the built-in volumes, was also left behind, and solution 2 was the best option for this building. So the existing halls were well insulated, and the interior halls were insulated, but not overly insulated. And this seemed for us the best option, both for heating and cooling and total energy use for the building. One aspect, of course, also was the daylight. So we added additional openings in the roof, as you can see here on top, that allows or that permits the natural daylight to penetrate the building and to also give natural daylight to the built-in volumes. At the same time, these new openings allow for natural ventilation of the halls, since in summer temperatures can rise. So now we have natural ventilation. And oops. So this is another view of the whole. And here we see the simulation result of the temperatures during the year. So in blue, we can see the outside temperatures, and in yellow, we can see the operational temperatures. And we can see that the biggest chunk of the time of the year, we have very nice temperatures between 19 and 25 degrees. In winter, since it's not heated, in really cold times, so when it's -8 outside, we might go to 8 degrees in this hole, but still it's a covered city, it's not a heated space. So 8 degrees is still nicer than -8 outside. An architectural view of the site where we see the whole Gare Maritime, 270 by 150 meters with the built-in volumes. So we've got 10 big volumes of 4,500 square meters and 2 little volumes that are a bit more technical, but that also have commercial functionality. And this is a picture of the final result in place of that main event square, as it's called, with on the right and on the left side the built-in volumes. A section of the building indicates how it has been integrated. So we can see that here are volumes, what we call really under the roof of the building. So there's no possibility to integrate chilled ceiling, climatized ceiling. Here we have a climatized ceiling here also. And what we do here is we've got trench heaters with an integrated fan that can also do cooling. So the ventilation also comes from the raised floor, as we can see in this little Revit image. In the ventilation, there's also integration of adiabatic cooling and an extra heat pump to dehumidify the air for the climatized ceiling zones. And what is special about this project is the geothermal ATES system, so the aquifer thermal energy storage system, which is a prime for Belgium and certainly for Brussels. Brussels is a very tough region to realize open source geothermal solutions, since the aquifer indicated here in the orange zone is not so productive. What we did now, so a classic solution, so is the red borehole that we see here normally goes to 70, 75 meters. What we did here is we really drilled a bit deeper until we hit the rock of Brussels, and we added the pipe, and the hole is cemented, and then we continue to drill up to 150 meters in the rock, and we have a capacity of the geothermal system that is up to 7 times higher than a classical sand layer system in Brussels. So this allows for such a big buildings to use geothermal energy and to use heat pumps. How is it laid out in the Gare Maritime? In red we see the geothermal boreholes. This was coupled in a geothermal loop that goes to a central building where there's a heat exchanger, and then the secondary loop distributes the geothermal energy to the different building blocks, where we've got heat pumps integrated in every block over there. And here's also another additional heat pump for what will become a food corner later on. A nice picture of the roof still, where they added 17,000 square meters of PV panels for 3.4 megawatts to realize the energy neutrality of the building. Additionally, on the BIPV that has been integrated in the south facade. So I think it's a real nice building, both from an energetic point of view, a sustainable point of view, since it's a reuse of a site that was left behind and that's now completely revived, and architecturally, I think it's a big success also. And I hope that once COVID is behind us, that the building will have an interesting life with lots of nice events. I hope you like it too. Thanks a lot.
Yeah, thank you very much, Thomas. I leave it to you to comment on it.
Yeah, so it, as I mentioned before, it fulfills 100% what we expected, more or less. So there have been really a lot of nice pictures, and there's also some obligation coming with the prize to you. You mentioned a little bit in the post-Corona time. I think we have to go there and maybe find some beer garden or a restaurant in there to drink beer and to have a nice visit there, because it's really interesting. Really good job. Thank you very much.
Thanks.
And also for me, a very big congratulations. I think it's an impressive building. Is it open at the moment? It's ventilated. It's
yeah. The offices are in use for as much people that use them, but and also the public square is open and accessible for everybody already. So you can visit the building if you want.
Very good. Thank you very much once more. Congratulations. Enjoy the prize together with the architectural prize. I hope
thanks a lot, and thanks for the prize.
Together.
Very happy with it. Thank you.
Super. Good. Then we continue with Jussi here, one in a long-standing judge in this. And Jussi, I just checked with Serena. It's the 10th edition of this award. We will do it like with EHPA. It's the 20-year anniversary with EHPA, and parties are not very good at the moment. So since we are good party people, it doesn't show on Zoom, but we are really, you can believe that. We will have a nice party at the 11th edition, hopefully next year. Jussi, you will talk about the next generation heat pump prize. And now the audience will maybe ask themselves, are you crazy guys? Why are you mixing this up? Next generation heat pump should be the last one. Yes, but Wim Boydens, who is presenting the last prize, had some, initially at least, some time constraints, so we switched the two. And that leaves it with Jussi to talk about the next generation heat pump prize and to hand over the award. Jussi, please.
Thank you, Thomas. Thank you for a nice introduction, and it has been really a pleasure and honor to be to remember and see all those 32 excellent applications, and today award the next generation heat pump category award to someone. It has been really a tight competition and a lot of excellent application, and one of those was best for that category also. This next generation heat pump, it is nowadays very seldom heat pump, it is always system or solution or integration, as you, Thomas, mentioned in your introduction. From this application, I have to mention, or it was a feeling of a real seamless cooperation of planning company, heat pump manufacturing company, projecting and installing company, and of course with a client. And it was very innovative, cost-effective, standardized factorial concept for all size of groceries of a big actor in the country. And maybe the most important thing is that it was very easy to repeat in all of the hundreds of small and big groceries which that the client has, and that means big CO2 and energy savings in every city of the country. So I have a pleasure to award application called Energy Recycling System for Grocery Stores of Kesko Oyj. And it will be presented by Dr. Tuomo Niemela from Dyrelund Consulting Limited. You are welcome, Tuomo.
Thank you very much, Jussi and Thomas. This is a great honor. Yeah, I want to thank everyone for getting this nice recognition. There were lots of very high quality application, and it's very nice to get this recognition from our hard work. But I think we are a little bit behind of schedule, so I'll get right on with the presentation and try to keep it brief. Yeah. So yeah, thank you, Jussi and Thomas. The title of our project was Energy Recycling System for the company called Kesko Oyj. It's one of the biggest companies in Finland and one of the largest like grocery store companies also around the world. So it's nice to give this presentation and get into details with our project. Yeah, my name was Tuomo Niemela. I'm a Chief Technology Officer at a company called Dyrelund, and like Jussi mentioned, I represent the design part of this project. So yeah, energy recycling system for grocery stores of Kesko, and the aim is to have the grocery stores almost emission-free and carbon neutral. And the heating energy consumption of the grocery store properties, it's reduced up to 95% with the help of this energy recycling system. Yeah, and I agree that this is quite innovative. It's not a difficult technology, but quite innovative. And I think the most innovative part might be this standardized operation or procedure where we use the same technology in every building. And it's as cost efficient as possible at the moment. Yeah, and the companies in the project, Dyrelund, that I represent, then Tomal and Senera, who is the contractor making the installations and the site installations and stuff like that. Then Gepwell or Gepwell Limited, which is the technology supplier, and Kesko, who is the client in this project. So basically 4 different parties and one big cooperation project. Yeah, and some brief in the technical side. Basically, these grocery stores, they are extremely energy intensive due to the refrigeration and cooling demands. And the basic principle in this concept is to recycle all possible heat flows from the grocery store to the heating of the building, and utilize them as efficiently as possible in the heating. And waste energy flows in these grocery stores, they include the major energy sources, of course, the condensate heat coming from the refrigeration system of the property and from the cooling systems like regular building cooling systems. And then these are existing buildings, hundreds of existing buildings built in the 1980s, 1990s, 2000. So there are some additional energy flows as well, like exhaust air from ventilation systems, meaning these kind of exhaust air units that don't have any other heat recovery installed in the system. And of course, in addition, the existing R404A refrigerant systems, they are also replaced to natural CO2-based systems in addition to this energy recycling. And that way we also improve the energy efficiency of the actual refrigeration system, not only this energy recycling system. And in the future, we can also extend this concept to utilize boreholes or air-to-water heat pump technology for additional heat production. And we can install this or extend the projects or buildings later on. But the main thing is this waste energy recycling system that we are utilizing here. Little bit about the project. I will go through this a little bit quicker, but one of the most innovative parts is that we are making comprehensive renovation and continuous operational development here. We are not just installing these heat pump systems, we are making comprehensive renovation, meaning that we are also renovating other HVAC and building services systems in addition to the actual heat pump technology. And it includes some project planning, initial information gathering, then this implementation, that what we are doing, for example, something for the air handling units, building management systems, and then of course the heat pump technology, and then monitoring, of course, for quality assurance and continuous development. So there are actually two phases in the project. First, the project planning phase. We want to know what is the original condition and situation in the building, and then make plan for the actual project, and then conduct the project so that it's as comprehensive as possible. So initial information and planning, then the actual project planning, and one main thing, of course, is the cooperation between different parties that we make as successful projects as possible, and then development, the final phase. And we are repeating this kind of process from building to another, so that we can repeat the same concept and get the most benefits that we can from this most comprehensive renovation process. Yeah, a little bit about the system, a little bit more detailed. This figure shows the basic concept that I already described. So basically we have this large energy recycling system, and the main thing, of course, is the heat pump system that is collecting energy from these sources. So the refrigeration unit producing the refrigeration energy needed for the groceries, milk and cheese and meat and so on. So we get the condensed heat from that system. Then we also collect waste heat from the exhaust air, depending on the initial situation or condition of the building. And then, of course, the condensed heat coming from the actual cooling, like the regular cooling of the building. And we utilize the heat pump system, collect the heat sources here, and then produce as much heat as possible for heating networks and for heating of domestic hot water as well. And like I mentioned, we can also extend this to utilize boreholes or air-to-water heat pump technology in the future for additional heat production. A few figures about the projects. So design phase, like Jussi mentioned, we have conceptualized this to a very high degree. So everything comes from the Gebwell factory, like prefabricated. You can see figures here that they model it in 3D, and they come to the site that we are doing the installations of the building site. They come like this. So everything is pre-installed, pre-manufactured, and ready to go. It's almost like plug and play installation. And for example, the installation time on site, it might be from 2 to 3 days, where it was 2 to 3 weeks before this. As you can see, lots of different pipe equipment and stuff like that, and tanks here. So we utilize the prefabrication, and Gebwell is the technology supplier that we use here, located in Leppävirta, Finland. A few more figures. We use this kind of modules. This is, for example, the heat collection module for the condensed heat of the refrigeration system. So we utilize this kind of modules because these are existing buildings, and not always you can get everything in place as one shipment. You have to modularize it like this. Figure from the site, the installation site. So here you can see some figures of the actual site where the installations are made, and of course precise welding and careful installation is required, but majority of the components and the system comes pre-manufactured from Gebwell. But this is quite high replicability or repeatability in this concept, also outside Finland. But a little bit about the results and potential that we have here. So we are going to conduct these kind of projects in over 200 buildings. So basically these city markets, they are like hypermarkets, and then supermarkets and some cash and carry outlets. And in addition, there are approximately 500 to 600 small grocery stores. We have another project going on where we design a suitable concept for these smaller buildings that might be located in a commercial building or in an apartment building and so on. Energy saving potential. Kesko is very ambitious to reach carbon neutral with their building stock, and the saving target of the entire Kesko Group is 105 gigawatt hours. And you can see that even with these projects that we are doing, we can already exceed their target. And this Kesko, they have lots of other buildings in addition to grocery stores. They have like car shops and stuff like that. So lots of other buildings besides these. So even with these energy recycling projects, we can already exceed their target. And in Finnish scale, this is very high energy saving potential compared to any company or any site here, even compared to the industrial side. A little bit of demonstration. So, like I mentioned, a total of 160 medium and large grocery stores are going to be conducted. And like I mentioned, there is a significant international potential so that we can copy or use this same kind of concept in other countries, especially in Scandinavia, but also I think in Central Europe and around the world. And here you can see like the average size of the project in the supermarket scale, about 150,000 and about 400,000 in these hypermarkets. Average energy saving potential per property very high, especially in the larger buildings. Also electricity, because in these projects, even though we install the heat pump system for energy recycling, we typically replace the existing lighting with LED lighting. Then we replace the existing refrigeration equipment from R404 to CO2. So we get additional savings from other HVAC systems in addition. Yeah, and quite high impact if you consider the average reduction in especially in district heating consumption, but we even get some reduction in electrical energy consumption. So very high like impact with these projects. Here are some preliminary results. I think the results from this year, the early part is not quite comparable due to the COVID-19, because in shopping or grocery stores and shopping centers and in places where people are a lot or lots of people are in the place, we have used very high ventilation airflow rate, and we are not using the return air or like we are not recycling the air back in the air handling units. So the energy demand has been increased, but all the buildings that we have like monitored so far, it seems that we are getting to the desired or simulated and designed saving potential. So in these smaller supermarkets, we get over 90% of heating energy reduction compared to the initial situation, and also in these larger city markets we get quite good impact and lots of energy saving like euros for the client as well. So this is quite profitable projects in addition to the large energy saving potential. A little bit about the advantage that we have here. So like I mentioned, scalability and replicability. We can use this in different types of buildings besides grocery stores, and we have used this same concept or almost same concept also in offices, commercial buildings, shopping centers, industrial properties, and so on. Then, like Jussi mentioned, of course, cost effectiveness, maximum prefabrication, and minimum installation time on site. So basically, this is definitely a strength. And of course, the energy efficiency. Now we know that this concept works. We have get measured confirmation that we save the energy that we think we are going to save. And I highlight one more thing here. We have this remote monitoring of the systems that it allows the optimization of each individual building, and it also allows preventive maintenance. So we can use this to preventive maintenance before something breaks or happens for the heat pump systems or different components of the system. Then some development areas. We are currently using R410A refrigerant, and it has been like acknowledged selection. We know that it's going to be needed to be replaced in the near future, but we are already for future projects. We are already in progress with Kesko that we get the next generation heat pump units with lower GWP value refrigerants, such as these R1234ZE. And of course, some replacement refrigerants is required for the projects, maybe 20 or 30 projects that we have been conducted with the R410. But I'm not so worried about this refrigerant choice. I know that we get this covered. And yeah, we have a upcoming tax revision in Finland, where we might get some reduction in the electricity price or taxation of electricity if we produce heat back to the district heating network. So up to over 20 euros per megawatt hour saving potential is possible here if the best case scenario comes up. And this means that we get different applications for this concept as well. Automatic control and monitoring and some machine learning features in the automatic side or building management side, those are in progress already. And of course, we get new heat pump technology with better efficiency, better control features and stuff like this. We are going to implement them in this concept when they are ready. Well, one figure of the tax revision, what it could look like. Basically these grocery stores, they can act as heat producers and sell excessive heat back to the district heating network. And I think this would revolutionize the energy market in larger scale, like municipality scale. We have data centers, industry, and grocery stores producing heat for the community. So this kind of concept, I think, might be possible within the next 10 years or maybe even earlier. Yeah, then some figures to the end. So basically, this is what it looks like when the installations are ready in the buildings. So quite a lot of technology, but we have handled this quite well and know the technology is working, and also know what are the improvement areas. So we are constantly developing this concept to be even better in these buildings or projects. Yeah, also some PV panels might be installed in the projects. This is one figure where we have this whole container coming from the factory. It includes all the technology and it is installed beside the actual building. So we don't necessarily need technical space within the building. We can also install these in a separate container outside the existing building. And here is this is how it looks like. So pre-manufactured coming out of the factory, and we are just lifting it inside the building and plug and play in the building. Okay, I think I have used my time, so thank you everyone for your attention, and thanks again for this recognition. It's very nice.
Well, thank you very much. Jussi, what do you think? Was it the right decision?
Oh, I guess it was just right decision. It was influencing presentation, Tuomo, and it is. I have nothing to add. It was great work, and it's this cooperation between different parties, client, you as planner, manufacturing company, and installing company. It is really what we need. Thank you, and congrats.
Thank you very much.
I hope the audience agrees, because what I took from this presentation is integration, prefabrication, ready to go. And this seems for me so important when we want to move from a situation where we prepare heat pump systems in bespoke manufacturing to a system where we want mass rollout. Thank you very much. Congratulations, Tuomo. I can remind everybody, if you like what you see, tweet about it so that we increase the visibility of these projects. And with that, we come to the last category, decarb industry. It's a bit of the same, just different, as we sometimes say. And Wim Boydens will present the winner in this category. Wim.
Okay. My video is not able to be viewed. Not that I have a problem with that. You might have a problem when you see me. Huh? Thank you, Thomas. So I'm very happy to comment a little bit on, wait a minute, start my video, I will try. I will comment a little bit on the last winner, the fourth winner of the awards this year. And of course, and we know it already, that the city is a very important stakeholder, and the city master planning of energy is very important to go towards decarbonizing buildings and moreover cities, and to do sector coupling within that movement. And we had a lot in those 32 submissions, interesting projects that go more citywide, more district-wide, more cluster-wide. And okay, even though it takes a little bit time to go through all of them, we have to make choices. And what the jury appreciated under that big amount of candidates working on that city and district level is here specifically the multi-vector approach, the large scale and the roadmap approach towards future improvements, and the mixed use of the involved buildings that are connected to the system. So in submission number 24, we see hybrid, carbon-free supply, and this also clean supply for district heating and cooling in the Kastrup area in Denmark. So selecting a winner among those many beauties is not easy. So we would like also to congratulate all the other projects with what they have accomplished and what they are putting into an acceleration. But of course, in special, the winner of the decarb industry, we would like to congratulate you, the Tarnby for Scening in Kastrup. So Mr. Anders, I suppose I give you the floor.
I think we start with Einer with the, yeah. Please go ahead, Einer.
Yes, thank you for the floor. And I will, time flies, so I will say something about the ideas behind the project. Then I give the floor to Anders Dyrelund from Ramboll, which is our consulting company. Thanks for the prize. And we are proud to win this nomination and will no doubt further strengthen our effort to be carbon-free. We always aim to have the most appropriate use of energy resources from an environmental and climate point of view. We have a CSR policy. We have an environment policy. We participate with the municipality in biodiversity and is strongly committed to the UN Sustainable Goals. In Denmark today, we have around 30% of our energy needs come from renewables. We expect to reach 50% by 2030. And by 2050, Denmark will be 100% independent of fossil fuels altogether. From around 1980, GDP has increased by 100%, while the Danish energy consumption has only increased by 6%, and water consumption has decreased by 40%. This proves that it is possible to create growth without using more energy. In Denmark, we see the green transition as an investment in future economic growth, market opportunities, and job creation. An example of this collaboration between the water and electricity sector, where sludge from wastewater treatment plant is used to produce energy. Another example is the synergies created in the co-generation of heat and electricity, where surplus heat from electricity production is used to heat water pipe into the district heating systems. And therefore, I will just say that, once again, thanks for the prize, and I assure we continue our work for the necessary great green transition. We are a small company, but we try to influence decisions making so the planet will also be habitable for the future generations. And then I give the floor to Anders Dyrelund, who will talk about the technical side of our project. Thanks.
Yeah, thank you very much. I'm just the energy planner. We've just heard Einer, president of the Tornby multi-utility. Here you can see some overview of the little Tornby municipality, a part of Greater Copenhagen. But what is of interest here is that this utility actually is responsible for water district heating, wastewater treatment, now also district cooling, and a service department to make sure that it all operates. But let's start from the helicopter, from the chopper. See here I have the Greater Copenhagen area, metropolitan area with 1 million people, heated from the same integrated district heating system with combined heat and power, as Einer mentioned, also heat from waste incinerators, but now also heat from combined heating and cooling. And here we have Tornby municipality. In this municipality with heat planning starting in 1980, we developed district heating, the light green area here, to supply 180 gigawatt hours district heating, and the potential for extending this market now, replacing gas boilers. It comes from the heat transmission system up here, the big system. We have a peak boiler plant at the airport just as a backup. And now, as a new thing, we have a potential for cost-effective large heat pumps, which can integrate the wind energy and load dispatch, optimize production in combination with the CSP plants. Now we zoom in and have a closer look at this business area here. What is of interest here is that you in this area have had a fantastic urban development. Because of the metro station and the train to Sweden, just south of here, there's been a very attractive new urban development. Sorry, here, a new building coming up here, and also existing buildings here being supplied with the blue district cooling pipes. The green district heating is already here, and here at the wastewater treatment plant, we have cleaned the air so there's no bad smell. We have the National Aquarium here. So what is interesting here is that we found it very cost effective to combine, use this economy of scale effect and supply all buildings with an integrated district heating and cooling system and generate the heating and cooling at a central plant here with a chilled water tank in combination with a big system where you have a heat storage tank and to use surplus heat from the wastewater when there's available cooling capacity. Here we see the new plant. This is the chilled water tank, and here we have the heat pump installation in this building here. 2,000 cubic meter, 6.5 megawatt heat and 4.5 megawatt cold capacity of the heat pump, connecting to the grid. Here's a little of how the cooling is generated. The total capacity of the cooling network is 10 megawatt, but combined with the storage tank and a ground source cooling in the next stage, we would be able to supply all this capacity and saving a lot of individual chillers in the buildings. The cooling energy is not that big, only 10 gigawatt hours, combination of process cooling and comfort cooling. From this cooling energy, with the heat pump, we generate the heat combined with the cooling, combined with the groundwater. But then, remarkably here, that most of the heat is actually coming from the wastewater treatment plant. And that is the way, that is really the gimmick that makes this project very cost effective. And all this heat is, of course, only generated when the power prices are modest. When you have peak power prices because the wind is not blowing, then we don't use any electricity. Here you see some of the installation works, the pipes, twin pipes, the big one for district cooling to the office building here, and the small ones for heating.
This is the pipe connection to the future district cooling plant of the Tornby Forsyning. Largest pipes here.
Going inside the building and see the heart of the system, namely the heat pump. You can see manufactured by Sapro, Johnson Controls in Denmark. And we have many of these actually have a booming market for these heat pumps in Denmark right now, replacing gas boilers. And here we go from the inside, see some of the pumps here. You see the control boxes here for the pumps, for the heat pumps. What makes this fantastic is that actually you can say that the pumps here circulate water in 5 circuits, from the tank to consumers to make sure they have cold water all the time, from the heat pump to the tank to make sure that the heat pumps, they operate as they like to do in an efficient way, and to be optimized with respect to the electricity prices. Of course, all heat from the heat pump is feed into the district heating system. We don't waste any heat. And then from the wastewater, a pipe from the treated wastewater is going to the heat exchanger, and the heat pumps can take some of the heat from the wastewater and cool it down to about 4 to 6 degrees. And finally, in the next stage, there will be also pumps pumping up groundwater to a heat exchanger so that it can cool directly in summer. And in winter, the heat pump can cool down the groundwater and actually take heat from the groundwater, as we saw also in some of the previous interesting projects here. HPCY system is really a good thing because it combines heat pump with storages. So all this opens for an optimization with respect to the electricity market, but also with respect to the heat market in the big Greater Copenhagen district heating system, where you day by day, hour by hour, actually optimize how to generate the heat in the most cost-effective way. When prices are low for electricity, the heat CSP will stop and all the heat pumps will run on electric boilers. And when prices of electricity increase because the wind is not blowing, then the CSP, of course, operates maximally, but all the heat pumps will, of course, stop. So this is actually a good case demonstrating economy of scale and also show that the big heat pumps has a market in the big cities. The total investments, including the heat pump, chilled water tank, and district cooling network, is about 10 million euro. The total benefits for the society of Denmark is 15 million. So it's based on the life cycle cost analysis, and the profit for the local community is even bigger now because we don't pay much tax on electricity for heating in the future. So it's really a very, very profitable project for the local community. And because it is owned by a Tornby municipal utility, all the benefit here goes to the municipalities, the electricity, not to the electricity, but to the cooling consumers and the heat consumers. And it is all of it is financed by very low interest loans. The big first consumers have paid connection fees, very good. Then the banks can finance the rest at a very low interest rate. Here we see a simple diagram. We have also a very more complicated one for those who are interested, but this is a simple diagram illustrating our system here in Tornby with a heat pump here, the heart of the system, the chilled water tank. And this is actually just illustrating the Greater Copenhagen district heating system, where we have several big CSPs, waste incinerators, and big heat storage tanks. But it's also an important part of the system. And here comes the ground source cooling in the next stage. We can say the heat pump will in future have a very big role to play in big cities, in smart cities, in integrating the fluctuating wind energy, surplus heat, also ambient heat of all kinds of sources. So we are very happy to Ample as a consultant to help the Tornby utility to establish this, to plan and to implement this project. And we are looking forward also to share our experience with the rest of Europe and the world. Thanks a lot.
Thank you very much, Anders. That was impressive. And I like that you could simplify the rather complex matter to a level that is understandable to many people. Wim, what's your final comments?
My final comment, quite inspirational, even more. So I would just say, even on a large scale, never waste a source of clean heat. And this is very impressive in this project. Thank you for realizing it.
Thank you very much. Yeah.
Thank you.
So we say thank you to the whole Tarnby municipality, to the city works, and of course to Roundball for helping. So yeah, I saw that you prepared some glasses. I brought one for you too. We are really delighted for this project, and we hope that we can multiply it in many municipalities across the world, I would say.
Yeah. As you say, this is teamwork. We have the whole team here. We have our politician, our president, we have the manager, and the district liaison chief, and we are consultants. So, you say?
Hey, Etak.
Hello.
Very good, very good. So with that, I see that we have only few questions. We had one question on the refrigerants. If the panelists could simply just type maybe what refrigerant they use. But me personally, I would be with Tuomo. The refrigerant discussion will come to a close. We see that the industry is fully online with the phase down of the F-gases under the F-gas regulation, and we see renewable and low GWP refrigerants popping up like crazy. There is components manufactured, so I think we can probably allow us not to give too much time on this. Then we see here, actually that was me. Tuomo, will Kesko roll out this project across Europe? Kesko is such a big player in the supermarket sphere. Will we see more of this in other countries? And Patrick, the question is Patrick's yes. How do you thermally balance the geothermal boreholes while there is only demand for heating in the winter? So what do you do? Maybe you could connect it to one of the systems that we have seen here from Rumble in Tarnby or even a supermarket. Does any of you want to answer to these questions directly, Patrick or Tuomo?
This is Patrick. Just as so, there's a representative from Kenza Online who can probably answer that technical question on my behalf. That's David Broom. If you'd like to do that, David, that would be helpful. It's beyond my technical knowledge in terms of the design of the system.
Okay. And maybe in the meantime, while we bring David online, if that's possible.
Hello.
Yeah.
I wasn't quite expecting that. Hello, everyone. Thanks, Patrick. So in these applications, we're designed for heating only. The boreholes are designed to sustainably provide all of the energy that the buildings need based on the thermal loads, and the ground kind of naturally recharges across the summer months. So we ensure that we've got enough energy available through the next heating season. So in these particular applications, because they're kind of in relatively small clusters, kind of spread out away from each other, that's how we've had to do it. But in the future, we definitely see the ability to be able to combine these systems with localized kind of cooling loads or any other forms of waste heat, particularly in the context of new build developments and mixed use developments, where you have the ability to take kind of either building cooling or process cooling or data center cooling into that ambient loop, and then use that as a recharge mechanism for providing heating and hot water to homes. But by doing the transfer on the ambient side, obviously we can effectively kind of provide sort of cheaper, more cost-effective cooling to those loads, while also improving the recharge and the efficiency of the heat pumps that are providing the heating side. So for this particular scheme, it wasn't viable, but we're certainly looking at other schemes in the area and larger schemes in the future where we will look to include kind of balancing the load with heating and cooling.
Thank you. Perfect answer to an unexpected question. So thank you also for being so flexible on your feet. And Tuomo,
thanks.
What about the multiplication?
Yeah, I think Kesko, now that we have got some very good experiences from Finland, so I think that they will definitely going to maybe expand this to other countries around Europe. So yeah, I think that's going to happen at some point.
Wonderful. I think then we have answered the questions that we had. We have given the prizes to all the prize winners. We have thanked all the contributors. I hope you had a great morning. For myself, I got an inspiration. I think we should have a calendar for 2021 with the 12 best heat pump projects. So that will go on the shoulders of my team. We tried to do it in PDF, and if you have great pictures, maybe help us there. And then I would like to thank you and close the meeting in time. Have a great morning. Have a great rest of the day and be inspired by heat pumps to be used across the globe. They are available. Bye-bye.